Hello, I'm Rebecca Barnes, and welcome to the Science Eater podcast. In this episode, our journey through the wonders of modern astronomy brings us closer to home as we begin to explore the solar system. We'll discover the scale and structure of the solar system, find out why we explore it, and introduce the European missions launched on a quest to further investigate our local celestial neighbourhood. Ancient astronomers observed points of light in the night sky that appeared to wander across the fixed background of stars. These 5 wandering stars, or planets as they came to be called, along with the moon and sun, are Earth's closest cosmic neighbours. Until about 400 or so years ago, a limited view and understanding of our solar system led astronomers to believe that our world was at the centre of the universe, and that the sun, stars and planets orbited the Earth. At that time, astronomers only knew about the 5 planets closest to us, those that are visible from Earth to the unaided eye. Over time, our view of our local cosmic neighbourhood has changed and evolved as technology and scientific thinking has progressed. Nicholas Copernicus was the first to realise that the sun was at the centre of the solar system. Johannes Kepler discovered that the planets moved in ellipse-shaped orbits, and Galileo Galilei was the first to use a telescope to observe 4 tiny moons orbiting the giant planet Jupiter, showing that more than one centre of motion existed in the solar system. The invention of the astronomical telescope provided the ultimate tool for astronomers to observe the solar system in more detail. In addition to facilitating the discovery of 2 more giant planets, telescopes also allow scientists to see the surface of the planets for the first time. Continued study of the heavens over the past few hundred years has completely changed our perspective of our place in the universe.
The solar system, a tiny region of our galaxy, is dynamic and is in constant motion and evolving. Although small in size compared to the Milky Way, the solar system is actually very large. Our solar system formed from a large cloud or nebula of gas and dust about 4.6 billion years ago. This cloud mostly consisted of hydrogen and helium that formed in previous generations of stars. This pre-solar nebula was a rotating sphere of dust and gas. Slowly, the dust settled around the central plane to form a disk. At the center of the nebula, a protostar formed. Further contraction in the heart of the protostar caused the temperature and pressure to increase until they were high enough for nuclear fusion to ignite. In the disk of debris surrounding the very young sun, heavier elements remained closer to the central star, whilst lighter elements were pushed by the solar wind to the outer regions. The dust and gas, whilst settling into a disk, started to accrete. Some material was broken down into smaller pieces, and others began to cluster together and stick. As these clusters grew larger and larger, they attracted even more material and eventually formed the planets observed today. The sun is the central engine of the solar system. It is by far the largest body providing light and energy to all other objects that lie within the system and that are held in orbit by its strong gravitational influence. Closest to the sun is a group of our terrestrial planets with solid rocky surfaces: Mercury, Venus, Earth, and Mars. Beyond the orbit of Mars lies the main asteroid belt, containing thousands of chunks of rock that vary in size and tend to be irregular in shape. Traveling even farther from the sun, we reach a group of 4 giant planets which have no solid surface. These are the gas giants Jupiter, Saturn, Uranus, and Neptune. Past Neptune, hugging the plane of the solar system, is the Kuiper Belt. The thousands of objects here, so far away from the sun, contain much colder material and are predominantly made of ices and rock. These are comets. The Kuiper Belt is also home to 3 dwarf planets, Pluto, Eris, and Makemake. Even further away from the Sun, the Oort cloud forms a halo surrounding the entire solar system. The Oort cloud is home to millions of comets. The outer boundary of the solar system is known as the heliopause. This is where the solar wind, energetic charged particles emitted by the Sun in all directions, collides with incoming particles from interstellar space. Many of the planets have moons orbiting them, and the entire solar system is filled with microscopic particles of dust.
But why do astronomers and scientists want to explore the solar system? It's human nature to seek knowledge of the world around us. The solar system could be considered as a laboratory that allows scientists to explore physical processes seen elsewhere in the universe. For example, the Sun is the only star that can be studied close up. If as much as possible is learnt about the siblings of the Earth, such as Mercury, Venus, Mars and the Moon, then scientists can build up a deeper comprehension of the history of our own planet and what might be in store for its future. For example, on Earth, processes such as water flow, plate tectonics and the growth of vegetation have constantly changed the landscape and hidden a lot of its geological past. Whereas these processes are not active on Mercury, Mars or the Moon, so they preserve a record of the solar system's history. Ultimately, scientists want to explore in depth and compare the properties of all solar system bodies, including the Sun, in order to reveal and understand their composition and the processes at play, together with how the system formed and evolved into its present-day state, and how it will continue to evolve in the future. At the dawn of the space age, very little was known about what the planets were like as individual worlds. Venus was believed to be concealing lush rainforests under its thick clouds. Images taken by the first mission to fly close to Mars were expected to provide us with more clues about the big question, did life ever exist on Mars? Major developments in the technologies used in ground-based telescopes have made a significant contribution to knowledge of the solar system. However, over the last half a century, launching spacecraft above Earth's obscuring and turbulent atmosphere has allowed for huge progress to be made in solar and planetary science. Perhaps one of the most important advantages of launching into space to study the solar system is evading Earth's protective atmosphere, which blocks a large portion of the electromagnetic spectrum.